Machine intelligence and human intelligence. So I've more or less redone the talk since Aaron and I had lunch, and I suspect stuffed in way too much stuff. So I'm going to try and take the first part of it quickly so that I can get to the second part, which I think is really more about interfaces and some of the more interesting and profound questions that I think are facing us right now in this work, in this field. So a couple of quick words about my group at Google. We do a lot of machine perception, and that's something that I did quite a lot at Microsoft as well before coming to Google, especially visual. And we do a lot of work with machine intelligences on the edge, meaning not running in the data center, but running on devices, which is something that I personally feel very passionately about. And maybe by the end of the talk, it'll become clear why I think that's so important, why I don't think that all machine intelligences should be running up in the cloud. And so when we say on the edge, of course, we mean primarily today in phones and in wearable devices, although eventually that'll probably be other places too, out there in the world, in our bodies, elsewhere. And we also do a little bit of science. We have some connectomics collaborations going with the Allen Institute in my group. So the three questions that I really want to focus on are about the future of machine intelligence and what does the future look like for us, for humans, and what does that mean about the interfaces? So I'm going to start with machine intelligence and point out that I've been using the term machine intelligence because I think that the term artificial intelligence, which is a little bit older, has been freighted with a lot of bad baggage. And you know, if I were to characterize what artificial intelligence looks like, it's a lot of classical techniques for doing things using logic and induction and symbols and natural language and so on and so forth that doesn't bear a whole lot of resemblance with what we actually do inside our own brains. The thing is that what we now consider to be machine intelligence, which is really much more analogous to what's going on inside our own brains and this AI kind of stuff, these were really kind of birthed at the same time. And I think it can be taken back to von Neumann and earlier, but it's interesting, I think, to notice that in Turing's original paper, in which he invented the whole idea of computation, he talks about both of these forms of computation, about one that is that came to be known as the Turing machine and the computer, in which you have serial computation, you have an instruction set, you have a memory tape, and so on, and another in which you have neurons, and the neurons compute in a way that's much more analogous to the way brains do it. So those were both formalized with Turing, but throughout the 60s, 70s, 80s, 90s, the procedural kind of Turing computation approach really predominated. And they were definitely not thinking machines, slogans notwithstanding. So, a machine that could play checkers really effectively, like by evaluating the tree of possible games exhaustively and picking a move, can't be said to be thinking about checkers in the same way that we think about checkers when we play, even if it can beat us. And all of these kinds of things, decision trees and expert systems and agents and blackboard systems and knowledge representation, information retrieval, natural language processing, all inherit from that serial computing legacy. And I would say that things like Deep Blue and Watson are the kind of are recent inheritors of that tradition. A lot of interesting stuff going on with those systems for sure, but I think that they have very little to do with what an animal like this can do in its head. Right, so this kind of animal can't solve any of the problems that the systems on the previous slide could solve, but they're very closely related to us, of course. I mean, we're more or less the same thing. And what I think that really highlights is that for us, language and logic and so on is done in a kind of steampunk style, and it rides on top of a very, very sophisticated system that is primarily about perception and action in the real world, and about making sense of complex environments, and about predicting the future. And all of these kind of higher level constructs we do in this, well, again, steampunk I think is kind of the right word. We use that machinery by analogy and by metaphor to do higher order things, but if you somehow start by assigning predicates and verbs and nouns and so on to those higher order things and believe that you can get back down to basic stuff like perception and predicting the future, that's a road that's been tried unsuccessfully for many decades now. And I think that really for the first time, we're now starting to make progress at this more biologically inspired, more brain-like approach to things. And that's been very, very exciting. So what was happening on the machine intelligence side, on the neurons side of things for all of those decades? Well, mostly regression. So things like radial basis function networks, which were very popular a few years ago. If you look far down on the Wikipedia page, it says that it's, really just least squares with some funny basis functions. Or AdaBoost, which was very popular for a while, it's regression. Okay, so that was what neural nets were doing for a very long time. But nowadays, of course, we hear a lot of things about hierarchical feed-forward networks and recurrent networks and reinforcement learning, and especially these technologies, convolutional neural nets and LSTMs, long short-term memories, and temporal difference learning, other forms of reinforcement learning. These are the things that, when applied with very large training data, usually, and with deep systems or systems that have many, many layers, many free parameters, are now solving the kinds of problems that eluded those classical approaches for so many years. So, I could now spend the next 45 minutes talking in detail about some of these different approaches and what they're achieving and why, but I actually think that I'd like to skip over a lot of this stuff because I suspect that many of you know about these advances and about why they're so interesting. So let me skip it. Let's skip over neural Turing machines. Let's skip over how classical feed-forward networks work and what their loss functions are. It's okay if I skip this, right? It's okay. It is worth noting that one of the really cool things that happens is that when we train something like a convolutional net, we observe kernels getting learned at the lower levels of those things that look a lot like the spatial receptive fields in early visual cortex. So that's really new and interesting, that we train something to do something, and we observe when we do kind of neuroscience on those artificial systems, things that look very analogous to what we observe when we do neuroscience on non-human primates, for example, or even in humans. That's at low levels of visual cortex. You look higher in visual cortex of these artificial systems, and you see sensitivity to complex shapes and patterns and pieces of objects and so on. It's really pretty cool. Training with big data, we know this story. And of course, there are lots of tricks to how you bulk up data when it's not big enough, but that's all technical details. These techniques are beating every classical technique at every kind of perception task nowadays, even classical computer vision. Category recognition, this was completely insoluble 3 years ago. Like looking at this picture and recognizing it as a bottle of red wine. 3 years ago, 4 years ago certainly, completely hopeless. And nowadays there's an app on my phone that does it. And this is a kind of a cool paper that directly compares the performance of convolutional nets with representation of categories in macaque brain. This is pretty interesting. So starting to really relate directly the neuroscience of artificial nets with the neuroscience of real brains. Cool reference, and I think I'm allowed to put up screenshots from arXiv, right? That doesn't violate my form? Okay. And I'll skip the difference between how we do, for example, landmark recognition now or category recognition now and how we used to do it, because again, I think you all know this story. This is kind of a cool thing, actually. So this is a network that tries to figure out where an image was taken. And so this image of the Rialto Bridge could be either in Venice or it could be in Las Vegas. And so this is a network that directly maps the appearance of that image to a grid on a cell in the world map. And it's trained with a whole lot of data, and it kind of magically solves this task, which is really pretty cool. And images that couldn't be localized using conventional computer vision methods, like this picture of a beach. It sort of knows which beaches look like that as well. So it's solving these kinds of problems using very, very different techniques from normal feature-based SIFT-like approaches to computer vision. Or it knows that this picture was probably taken around 1971, and this one in 1945. Pretty cool stuff. Much more like the kinds of things that we can solve in our own brains. Or this one in 1968. Actually, its prediction was 1965. I guess because it's rural? I don't know. So perception is really getting solved in a very dramatic way by these new systems. Description of images, I think many of you have seen things like the mapping from images to captions that has come out of Google in the past year. Translation from one language to another using sequence-to-sequence learning. Very, very powerful and impressive. Dialogue generation. Robotics. Gaming. And synthesis. The synthesis one is sort of fun because this really has just happened this past summer. Typically these different approaches to machine intelligence are used to extract meaning from the world, to sort of map things down into an abstract category. But the problem of taking the abstract category and generating a stimulus that looks like the abstract category, doing art basically, or imagining, that's something that we really have just started to see over the summer. I'm sure many of you have seen the deep dream images that started to go viral a couple of months ago. A couple of the people who are now in my group started that. One of them is Alex Morvintsev, another is Mike Tyka. After one of those images leaked, we had to put up a blog post about it. For those of you who haven't seen these things or don't know how they work, this is a quick illustration of how it happens. So you take an image, this is just an ordinary picture, and you feed it into one of these networks that understands categories. So the most popular ones that I've seen used in the last few months are trained using ImageNet, which is, I believe, 1,000 or 10,000 categories. And then after after a few layers of this network have processed the image, you crank up the contrast of one of those semantic layers, and then you start to modify the image itself in order to enhance its meaningfulness, if you like, in order to figure out what would have cranked up the contrast even more. And this is actually something that Alex Morvintsev invented in order to try to visualize what different neurons in the artificial neural network were doing. But the results are really pretty cool. And they sort of add higher and higher frequencies to the image as you do this gradient descent in image space. So after one iteration, you get that, 2 iterations, 3 iterations, 4 iterations, 5, and you get this kind of crazy Buddhist kind of fantasia emerging out of the clouds. This is pretty, I thought this was pretty breathtaking when I first saw it. If you start off with white noise and you light up a neuron whose meaning you know, like hartebeest or measuring cup or banana or screw, you get these kind of disjointed hallucinations that look like that noun. We've been playing a lot with different ways of making these hallucinations more coherent. That actually can be done. If you light up neurons lower in the net, you get lower level features getting enhanced. Maybe a little bit like what certain drugs might do in a human. And Mike tried, since these things add high frequencies, you can alternate hallucination with zooming, which gives you a pretty cool effect. So you hallucinate, you add some high frequencies, you zoom in, that takes the high frequencies and turns them into lower frequencies, and then you hallucinate again, and you get this kind of stuff. So as some of you might know, Washington State recently legalized pot, and for recreational use, that is. And I gave a talk a few weeks ago at an event called Higher Education, in which everybody in the audience was supposed to be stoned, and I showed them this. It was a lot of fun. Well, you get the idea. The network really, really likes eyes, as it turns out. And I've started to think that maybe eyes look the way they do because neural nets like them. But anyway, that's a whole other conversation. Style transfer, very interesting paper from Matthias Bethke that some of you may know about as well. All right, let's change tracks now. How much time have I got left, Eric? 25. Good. So, what's the future of machine intelligence? I think that we really are on a track now that's very, very different from the track we've been on with machine intelligence for the past 50 years. I don't think that machine intelligence, or artificial intelligence, I guess I should say, was tending towards something that could do what humans can do. I think it was tending toward things that, of course, humans can't do, like, I don't know, computing the products of 20-digit numbers or something, but certainly not solving the kinds of things that humans can solve, not doing the kinds of things humans can do. And I think that now it is. These systems look like brains, they work like brains, they solve some of the problems that we solve. We're by no means there yet. There are a lot of tricks that it's very clear we still have to figure out. We still have to figure out how lateral connections and recurrence really work. We have to figure out how feedback and how embodiment work, and how it is that these systems can turn back around and modify the environment and then have the environment feedback into the training of the system. We have to figure out how to do learning more efficiently. There's a ton of work to do, but it seems to me that we're now well along that trajectory in which we build things that really are intelligent in the same senses that we are. And that raises a lot of really fascinating questions. So let's talk now about interfaces. Since that's what the conference is supposed to be about, right? So I need to make a disclaimer that I'm going to talk for a second about the company of a friend, and I'm an investor in this company as well. It's called Mochi, or actually it's called Voxa, but the product is called Mochi, which is a little confusing. It's an electron microscope, and it's the smallest and cheapest and lightest electron microscope in the world. Makes beautiful images, like a lot of electron microscopes do. Now, electron microscopy is a very old thing. The electron microscope was around when Turing was inventing computing already. This is an old one from the mid-20th century. And this is a new one, which looks just the same. And the device that Chris Owen is making looks like this. So it's about 20 by 20 by 26 centimeters and weighs less than 15 kilos. And that's it getting used in a restaurant. So this is a pretty cool thing. And I would say, this is a good example of taking an old technology and doing it right. Going back and doing the thing again, doing it the right way, designing it from first principles, and disrupting an entrenched market in that way, and commoditizing and democratizing, which are things that we see a lot with companies that really go back and rethink things from first principles, and also a cute name, which is a must-have for any company that does this kind of stuff. Right, so these are other examples, I think, of companies that similarly, earn my love by doing a lot of this kind of stuff right. I put in one or two controversial ones there as well, just to make sure that it wasn't all totally feel good. But companies that do this kind of first principles design, disrupt, commoditize, and democratize, and all have cute names. We all hope that we're part of a company like that at some point, I think. But that's not actually what I want to talk about with respect to Mochi. What I want to talk about is the fact that its interface is a phone or a tablet. And that's also something that's not true of any other electron microscope. Most electron microscopes out there in the world today in production either have their own interfaces or have software that you load onto a PC and you connect everything in a kind of very old school way. But Mochi runs on an app. So the interface is an app, and the app runs on your device. And I think that that's interesting, and that's just as much of a disruption, I think, as the change in the physical form factor of the microscope itself. I liken it a little bit to the way there used to be these things called car phones, which were part of the car, and now there are just phones that are part of you and that you have in the car, and that the car connects to when you get inside. So I'm going to do some sort of ghetto sketching. That's a person, and that's a piece of technology. And the way technology used to work is that the person had to adapt to the technology, go to the technology. I mean, in the ancient days of computers, the computer was a room, and you had to go to the building to use it. And nowadays, of course, technology adapts and comes to the person instead. And I think this is the essence of what natural user interface is all about. It's about the technology adapting to the person instead of the other way around. And the ultimate adaptation, of course, is when the technology starts to become so small and so intimate that it fits in your purse or in your pocket, and you take it around with you everywhere. And that's where we are now. Right? We're in this state. Justice Roberts, in what I think is a very, very important ruling by the Supreme Court a couple of years ago, said, modern cell phones are now such a pervasive and insistent part of daily life that the proverbial visitor from Mars might conclude they were an important feature of human anatomy. Now it's the person who is not carrying a cell phone with all it contains who's the exception. According to one poll, nearly 3/4 of smartphone users report being within 5 feet of their phones most of the time, with 12% admitting that they even use their phones in the shower. All right, so that's where we are now. And something like Mochi is just saying, well, the interface of the machine out there is projected onto this personal technology that's more or less fused with your body. So this really reconfigures in a fairly dramatic way the way we think about what it means to be an interface and where those boundaries get drawn. Now, what's really going on, of course, is that Mochi is a service and it lives in the cloud. And that's why you can not only use a Mochi device with the Mochi app when you're right next to the microscope, but you can use it across town. And that's pretty interesting because in a way you've just virtualized the microscopes and you've made it possible for people to do remote science and remote education and all this kind of stuff. And it means that there is this many-to-many relationship established between all of those Mochi devices and the people who might be using them. And there is a cloud service brokering all of that. So the personal screen is becoming the interface to all things. And a lot of this stuff that we've seen in this conference follows this same pattern, right? There are physical things and computational things that are all mediated in one way or another by interfaces on our own personal screens. And it's all internet connected. Actually, not internet connected, but cloud mediated, which is, I think, a very different thing. An internet connected microscope would be one that had its own IP address and that your phone talked to directly over the internet. But that's actually not the way things work if you have a cloud service. Things are going up to a centralized cloud service and then back down. And that centralization is a very different kind of architecture. It's a hub and spokes architecture relative to the way we tend to think about the internet as it was, I guess, back in, 2003 or something, ancient history. So Uber is a great example of that, of course. There's a physical thing, the car, and there's an app for it. And there's not only an interface if you're the user, but there's an interface if you're the driver as well. I mean, this interface on this phone is just as important as the one that you use to make the call. So in the old days, this boundary between the person and the screen and the device was what we meant by user interface design. And if we go back, I had to use Comic Sans since we're taking like a trip through time, right? UIST 88, God knows how many years ago when this conference began, the proceedings of the first annual ACM Symposium on User Interface Software and Technology, all the papers were like this, right? Extensions to C for interface prototyping and an overview of the X toolkit, the Mirage rapid interface prototyping system, building user interfaces by direct manipulation, right? It's all about how to make interfaces between one machine and one person. And obviously that's not what most of the papers presented here over the last few days have been about at all. So Uber is a paradigmatic example. First of all, we have to draw the cloud in the center because it is a hub and spoke system. And the Uber server is in the middle. It's mediating all of those interactions. There's a user with a phone, and the cloud connects to the phone. And there's a driver with a phone, and that phone also connects to the Uber cloud. That's my half-assed attempt to draw a car. And I've drawn here dotted lines where there are interfaces of interest. There are interfaces between the cloud and everything that it touches. Those are programmatic interfaces when they happen between the cloud and the phone. And there are interfaces between the phones and the people. And there's also an interface, although it's not controlled by Uber, between the driver and the car. Right? So it's a more complex picture now than we have with UIST 1988. And of course, there are a lot of other drivers and a lot of other users too. Now, Uber turns out to be working on machine intelligence to drive the car. I was pretty sure that Uber was doing that well before they announced it, because they've already set up this perfect system that connects people to transportation. And notice that there wasn't an existing interface between the driver and the user. In a way, Uber's innovation, right, the fact that you don't have to pay because the app has already paid, the fact that you don't have to tell the driver where to go because you've entered into the app, right, the fact that you don't have to interact with the driver at all, that's the innovation. The innovation is actually the absence of a user interface between the driver and the user. And because of that absent user interface between two people, it's possible to drop in a machine intelligence where there was a driver and have everything work as it did. So that's obviously the interesting play to make if one is Uber. So you drop in a machine intelligence, you connect it to the car, and you connect it to the cloud. Those are two more interesting interfaces. And then you can get rid of these things. Not the cars, but the drivers. So there are a lot of big pros. I don't want to make this sound dark. Google has a big self-driving car effort too. And I think both Uber and Google and Tesla and many others believe that I'm sounding like Citizens United. There are a lot of people in those companies who believe that humans are really terrible drivers and that we're going to avoid what amounts to an ongoing kind of genocide by putting machines at the wheel. There won't be a wheel anymore, eventually. So it's a good thing, I think, by and large, to save all of those lives, to reduce the environmental footprint of cars, to reduce the amount of asphalt, to reduce the driving time, to make the driving time productive. I could go on and on. There are a lot of pros. But there are also some interesting issues that arise when you take all the drivers out of the loop. And it's interesting to think about some of those cons. We'll talk about the labor aspect of those cons in a moment, maybe. But first, I want to just kind of talk a little bit about what it's like to be the user in this picture. There's a term that Mary Meeker coined a few years ago when she was talking about her state of the internet, asset light, that I think is very, very interesting. And what she meant by asset light is something that I related to right away because I thought back to when I went to university. So I went to Princeton, and I was kind of a misfit there, and it didn't go very well for me, and I was on academic probation one semester and stuff. But I lived in a dorm like this one. It was a very, very old dorm, and the dorm looked something like this. There was a fireplace, and this central room had two little rooms off to the sides. And of course, what this setup was for was that the central room was the sitting room, and one of the little rooms was the young master's room, and the other room was the servant's room. But by the time I got there, it was a quad, right? So there were bunk beds, and there were two guys over there and two guys over there and four desks. And when I heard that there used to be, this used to be like a servant's quarters and the young master and so on, all kinds of thoughts went through my mind, of course, like, white privilege, and they were all men, and they must have been a bunch of assholes, and, what must it have been like to be one of these privileged few and have to come with so much crap and so many servants and stuff, right, wagons full of stuff to university. But then, as one starts to think about it, well, Princeton in the 18th century didn't have a dining hall, as far as I know. It certainly didn't have working central heating. It didn't have snack machines. It didn't have laundry machines. It didn't have any of this stuff. And so, your servant was necessary in order to make sure that the room was heated by the time you got back from class. or in order to go and get you food if you needed it at night when you were studying. I don't think that quality of life for the young master was actually higher than it is for students nowadays at Princeton. I think it was lower. But they had to cart a lot of crap along with them in order to supply something that was not even as sophisticated as what any of us scholarship kids had when we went there in the 90s. So I did have a lot of crap when I moved in to the dorm, and it was in a lot of cardboard boxes. And when I moved out, I carted them between every year. Every time I switched dorms, I carted all these cardboard boxes. And I think back, what the hell did I have in all of those cardboard boxes? Well, there were a ton of books and CDs. And I would say that the ratio of the amount of crap that I had when I went to Princeton relative to how many boxes and how much crap somebody has now when they go to Princeton is about the same as the ratio between the young master and me. Because all of those things that I was looking around have now been dematerialized. And that's asset light. Right? So Mary Meeker is talking about asset light as a new feature, but actually I think it's a very old feature of technological advancement. It's about the way that we're changing our relationship with the world by virtualizing and dematerializing and distributing goods and services in such a way that ownership becomes more of a burden than it is a luxury. So that's my plot of log of amount of crap as a function of time. And I think that in most parts of the world and for most people, this is how it's going. I think it's going exponentially down. What's the limit? Well, way back when we had commons and public houses and so on, we took the idea of the sitting room and we virtualized it, if you like. Heating and cooking fuel virtualized. Food and cooking supplies virtualized the moment you have cafeterias and vending machines and things. Music, books, and movies Amazonized. Transport Uberized. Contingent labor TaskRabbitized. All right, no need for the servant anymore when you can, order people around on your phone. Housing, couch surfing-ized. Airbnb-ized, pets. There is actually a Japanese company that's doing pet rental with a smartphone app nowadays. Companionship, I don't know, Tinder, Grindr, clothes. If I had to make a guess, this is a wild prognostication, right? But I would guess that in 20 years' time, it'll be possible for you to wake up in the morning at your shared space with nothing but the clothes on your back and go to a kind of stall or a booth somewhere, and the booth will have a shower in it. You'll take off your clothes and you'll dump them in a hopper, and while you shower, the clothes will get recycled back into feedstock, and the clothes of your choice, kind of Netflix style or whatever, will be printed by the time you come back out of the shower. It's just a guess. And the last thing, I guess, that virtualizes is the device itself, because these things will, I think I would maybe swap device and clothes in this list if we want to make it temporal. But these devices are becoming very, very small. They're becoming very intimate with the body. Ultimately, they'll be inside us. And you won't be able to see them. Not quite virtualized, but let's say invisible to the point where it doesn't really register as a property, as a thing. And at that point, it's just you and your body. Maybe it goes further. Maybe our bodies also become redundant. I don't know. But that's about as far as I can see it clearly. So I want to close with some things to think about. I think that it's important to think about these interfaces between the physical and the digital, and that's one of the things that a lot of the UIST projects are doing. This is why things like 3D printing and physical drones and so on show up now and didn't show up in 1988. Privacy, surveillance, and individual rights are really important to think about. When one of these things virtualizes and centralizes, that also concentrates information and it concentrates power in ways that we, I think, want to think about pretty hard. Because it's a very easy step to take, and it's convenient, and in many ways it's very positive. I mean, I don't know how the Earth is going to support the populations that it's going to have to support for population peak in 2050, 2060, without a great deal of this kind of virtualization. But we should think about how those things are being done, and how it concentrates power, and whether there might be other ways of doing it. Many versus one machine intelligence. It's clear to me that there will be many machine intelligences, not one. And that starts to argue against some of this sort of centralization tendency, which we've seen over the past decade or so. You know, we have a tendency in Silicon Valley and in the tech world to look at the past 5 years and assume that that's the state of everything, of forever, right? I mean, I remember an article in Wired magazine called The Long Now that posited there'd be no more, like wars and no more economic recessions or depressions or whatever, sometime before the 2008 crash. Interfaces between machine intelligences and humans, I think, are really important to think about, how those work. And peer-to-peer connectivity. One of the things that makes all of the architectures look like hub and spokes right now is that somehow we've lost the ability for things to communicate with each other when they're right next door. And I think that's a very, very fundamental problem. Why, when you and I both have phones that have radios in them, can't they talk directly? I think this is something that people in this room should really think about and pay attention to. Because when they can't talk directly, that means they all have to be mediated by something central. And where not to deploy machine intelligence. I think that self-driving cars are a very obvious place to deploy machine intelligence. It'll save a lot of lives. It'll be good for the environment. Where are they appropriate and where aren't they appropriate? Stuff to think about. All right, and finally, economic redistribution. In a universe in which we start to have so many goods, so many services available to us, so virtually, so cheaply, and at the same time, we have taken a lot of the things that today are the basis of our own economic livelihood and removed the need for humans to perform those tasks. We're in sort of an interesting situation where the cost of goods is falling to zero, but the income for most people is also falling to zero. And this is not a stable condition. So I think that as this kind of stuff happens, I really don't understand any mechanism by which we kind of make it through without thinking very hard about how we take all of the surpluses that are generated by those falling costs and redistribute them in order to form a baseline such that everybody can eat and live at least a basic level. I don't understand how we get by without a guaranteed basic income or something very much like it in the next 20 years. And that's it. That's all I've got. Is there any time left for questions? Or are we... All right, great. Thank you.
Okay, so if you did all the sketches after lunch, that was very impressive. Nice car drawing. So it seems in many ways it's somewhat of a Star Trek potential future. You know, there's the unibody suit, and then everything else is being taken care of for us. What is the greatest sort of opportunity for, let's say, a graduate student? This is a question we had at the beginning keynote. What's the greatest opportunity for a graduate student to inject themselves in here and actually think about something that could make a difference in, like, the end of their thesis, or like a 30-year cycle, or even a 100-year cycle? Where do you think people should be spending their time? Because if it's the interface, that's a teeny tiny part of this entire equation, and I'm just wondering how big or small you see that interface.
I do think that the interface is a lot of where it's at. I mean, one of the reasons that I used Mochi as my example of transformation is that it's a transformation really purely via interface. I mean, Chris has done a good job of engineering that microscope, but there are plenty of physicists and and people who can make electron microscopes in the world. And what makes his device special and what makes it disruptive is entirely about the interface and the design. So I think that one can take the technologies that we already understand very well and, if you like, package them differently, think about the interfaces differently, think about the way the connectivity works differently, and wreak really radical transformations. So I'm not trying to discourage basic research, obviously, and I think that there's a ton of basic research to do. I believe, especially in machine intelligence, it's a place where I'm especially interested. But also in fun things like how to recognize an object via its electromagnetic emanations into your hand. This is really cool new building block, new tech. But yes, I think that a lot of the fundamental changes are in the way the interfaces are built and in the way things connect together. And that's the place where I think creativity can wreak massive and fast disruptions.
Hi, Lydia Chilton from the University of Washington. You had a great list of examples of companies and innovations that you said were sort of done from first principles, which is different, and I wanted to know what your take on what that process was like.
My take on what it means to go from first principles. I guess I put that bullet point up a little bit as a nod to Mr. Wait But Why, who just wrote what I hope is the last in his series of pieces on Elon Musk on his blog. He talks about Elon Musk as a first principles thinker, and I think that's basically right. What I mean by first principles is looking at a problem space, looking at an opportunity, and really stripping away one's assumptions about how it must be, how it has to be addressed, how it's always been done. I mean, it's crazy to talk about how things have always been done in an industry that is so young, right? And in which always been done equals the last 3 years. It's insane. But I hear that kind of stuff all the time anyway. It's amazing how quick we are to kind of lock into the way things are done. So that's really all I mean. Looking really with open eyes at the problem, at its basics, doing it with an aesthetic point of view, doing it with a set of convictions about how it might be done that are not about copying what's already happened.
Okay, good. This microphone is a tricky one. Patrick Bowditch mics up. All right. Let me try and keep. All right. Good. Patrick Bowditch, Hasselblad Institute. I was just tempted to say Microsoft because I see you. Well, I'm very excited about right now, and I'm very excited about fabric. In my lab at Hasselblad Institute, we have a lot of these debates about where this is going. So if I look at the past, we see a lot of things where we started digitizing things and making things like images. We could digitize those, we could make those, and film and so on. And for many evolutions, we're going to a slide about crap, right? Which is a great slide. And we're having this debate if at the end of the day, is it going to be VR or is it going to be fab? And so
I'm sorry, at the end of the day, it's going to be...
Okay, when digital photography started, I know lots of people said, why would I get a digital camera? We're talking about the 90s. I eventually have to print the photograph.
Right.
Obviously. And then that went away, right? We would just digitize, and we were just happy with the virtual, along the lines of what you're talking about. Now, right now, there's a very interesting development around physical materials. We can digitize those at the same time. I mean, at this conference, there were 3 or so sessions on fabrication. And one of the questions we're asking ourselves is, how's fabrication going to end? We're going to digitize, we're going to have models. What are our homes going to look like in the future? Are we going to, repopulate them with new stuff every week? Or are we going to sit into, a row of white cubes and just go and wear a headset? Or, any combination of those. Will be fashion waves for a couple of years. Will be, we will, so much crap, I've got more crap, and then next year we're going to be in an empty room again. Where do you see this going? It sounds like you're coming down on the empty room thing.
Well, actually, I have, I guess, personal wishes about this. Maybe I can express my wishes and then say something about where I think it might be going, which might not be congruent with that. I don't know.
Mm-hmm.
Obviously, there are different currents all coming at the same time. There is a current that says things dematerialize, it's the empty room, it's all rendered onto your contact lenses. And there's clearly something to that, something that is consumed as information, and ultimately everything is consumed as information for our brains, right? Can be rendered in some way digitally. And I think that that's a good thing with respect to a lot of different kinds of mass consumerism. And I sort of alluded to this when I said, I don't understand how we get through our population bottleneck without some of this happening. The idea of all of Earth's population having McMansions and a lot of physical possessions and so on is incompatible with our continued existence on this planet. So a lot of virtualization, I think, is necessary and is basically positive. Going around a city with Uber is actually in many ways a much better experience than having to own and maintain a car. On the other hand, I think that when one allows for that kind of dematerialization at will, it's also possible to invest things that are inherently valuable as physical and tangible experiences with greater value. And I'd like to think that things like the slow food movement or whatever are aspects of that, right? That if you don't have to worry about all this other crap, right, that maybe we can focus on the things that actually do matter about embodiment and our own physicality and things that actually matter and are not just mass-produced. I do see signs that those kind of values are not only held by me, I suppose, right? And I hope that those two things can coexist.
Juho Kim from Stanford and KAIST. One of the challenges as HCI researchers and UI designers we always face is to basically bridge the gap between how the system works and how the user understands the system. And as machine intelligence gets more complicated with deep learning and other more advanced examples, I think it's increasingly becoming difficult for us to bridge that gap because it's hard to explain how the system works and why the system works the way it does. Do you have any thoughts on how we can tackle that challenge in designing better interfaces?
Well, if you mean, I think that you mean that it's becoming hard to explain to people why machine intelligences do some of the things that they do, for example, or that our explanatory power, I mean, in a way we don't understand why and how deep learning works ourselves, even as the researchers who do it, right? So explaining why something happened to a person is even harder if they don't have that kind of background. I think that that's mostly the signs of immature machine intelligence, actually. If you have interactions with other humans in the world, then you have a very, very good machinery for thinking about how those things work. It's social modeling. You know that people can make mistakes. You know that they're not always predictable, but you can also build trust in them and you can model their behavior and so on. And I think that it'll be the same thing with MIs. As MIs become more sophisticated and more able to behave in a way that we can model socially, then it becomes actually quite easy to interact with them. And I think this is part of that natural interface kind of evolution. Right? The moment you can just talk and express your will in real language to an MI, then many, many things become possible that would take impossibly complex UIs today using a more procedural approach. So I think that's primarily growing pains. But that does posit that we need to have social interactions with those machine intelligences, and they have to be distinct and understandable as distinct units, and we have to be able to model what information they have access to and what not. That whole picture kind of breaks down if you think about things in a much more asymmetric way, like one giant machine intelligence that has access to everything. How do you interact with that? And now it becomes a lot less clear. Or how do you think about what it knows, what it doesn't know, how to work with it? Or if you have systems that are primarily geared to interact with each other and not with humans. Because, of course, the vast majority of the interfaces will not involve a human at all, right? So we have to really think humanistically about it, I think, and think about the MIs on a human scale as well.
Hi, Jifei from MIT Media Lab. So you showed an example saying that today there's I don't remember, 80% of people have to carry the cell phone every day, but I'm sure pretty much 99.999% of people have to wear clothes every day. Actually, you walk more than you take a Uber. So, and those are also a piece of technology. And so I'm just wondering, how do you think the machine intelligence can help or reboost existing industry like manufacturing, agriculture, and biology, etc.? Yeah.
Okay.
Does that make sense?
I'm not sure that I understand point about...
So my point is like, so basically and I think you have one slide saying that a lot of services we have in everyday life, like basically putting out in the cloud, and then you basically enhance that through machine intelligence, let's say, like you enhance this kind of sort of connectivity, and then that's a new piece of technology. But now what I'm just trying to say is that actually those type of interaction only exist a very small amount of time in our everyday life, because again, like the clothes is also type of technology. You are wearing it more than you're wearing a piece of a cell phone. So I'm just wondering, like machine intelligence as a tool. Yeah.
I think I understand the question. Let me turn the question on its head, perhaps. Imagine that you were naked and in a room with nothing but a phone, and you're not allowed to see anything in the world or anybody. Well, if the year is 1999, then this is pretty bad. It's pretty bad shape for you. If the year is 2015, then actually there's very little that you could not do with just the phone naked in a room. You could have relationships with people, you could do most kinds of information work, which is nowadays most kinds of work that pays. You could do most kinds of social interaction, most kinds of entertainment that people think about when they think about entertainment, right? So we really, you know, there is some sense in which we're already much more in that brain and vat situation than I think we understand. You know, all of us do work, except, well, no, those of us who are doing work with our hands to make interfaces with the physical world are not quite in this situation. But those of us who are just programming, for example, and showing up at conferences like this, could totally be replaced by an intelligence, either human or eventually non-human, in a blank room with a phone. You've sort of already been Uberized in that sense. Is that good? Is that bad? I mean, I don't know. I think it's both. I wouldn't recommend sitting in a blank room naked with nothing but a phone for the rest of your life. I think embodiment is important for human dignity, and there are a lot of things that we should be doing physically out in the world with each other and with the world. But we've already created the conditions under which, for example, for work, that's not necessary for the majority of American workers. Not true globally yet, but certainly true in the US.
So we have time for one last question. One burning, awesome question. Here we go. The high point of the conference.
Hi, I'm Jingyi from Berkeley. I really liked the brief mention you made to like power distribution and how we should take this into account in one of your slides. And I was wondering if you could expand on that, what your vision of like an ideal, I guess, power distribution within this community is, and what steps or regulations, if any, we should take to achieve that.
It's a little hard for me to say something that's not going to sound waffly about regulation. I mean, that's a big and complex thing. It's very clear that regulation has not caught up with the realities of technology and of how things actually work. And the ways in which it hasn't caught up are very different in Europe than in the US. You know, I think both have big problems. Europe's arguments about right to be forgotten and kind of its take on privacy, I think, I'm very sympathetic to the desire for a greater privacy, but I also think that there is a kind of flat-footedness about the European approach that's not particularly savvy about the way these things actually work. And on the other hand, for example, in the U.S., the lack of regulation on the government, right, to protect people's data in data centers from government snooping, I think is appalling. The lack of response to Snowden, I think, is appalling. It's a lot more than a 3-minute response to say, like, what do I think should be done with respect to regulation? But fundamentally, I think that and it's probably not something that I should be saying in public anyway, but fundamentally, I think that we need to think about human dignity and what it is that should be the rights and the dignity of the individual and of our species, of our society, and take the steps that are necessary to create the conditions where that can happen. And I don't think that we're really quite there.
Okay, so I think on that question of who am I and what does it mean to be human and what does it mean to be have an identity, I will thank Blaise very much for joining us, and thank you again.